Hey guys, welcome back to the fourth video on hypothesis tests. This is going to be a hypothesis test for proportions, so let's get to it. A company claims that 30% of their shoppers are returning customers. So that is supposed to be the true proportion, okay? They never took a random sample, they just made this claim. In a random sample of 420 shoppers, now that's your N, 135 shoppers were returning customers. So your P hat is going to be 135 divided by 420 because P hat is what we call the sample proportion. Do we have sufficient evidence to say that more than 30% of shoppers for this company are returning customers? Okay. And then I should have said, but even though it did not say, this is the key word here, sufficient evidence, but you should choose an alpha. I would always choose alpha equals 0.05, okay? So let's do this. First, step one, hypothesis. Your null and alternative hypothesis has to be either mu equals or p equals. It has to be parameters. In this case, since it's proportion, we're going to use p. So P is equal to 0.30, P is greater than 0.30. Your null hypothesis should always be equal, okay? And then I got greater than from here. All right. Be sure to define your variable or your parameter of interest. And here I wrote where P is the true proportion of returning customers, basically for this company. So it has to be the true proportion. Step two, conditions. So there are always two conditions. I'm going to take care of the approximately normal first. I have to check n times p and n times q if they're greater than or equal to 10. This is the only case from confidence intervals and hypothesis tests, the only case where we're going to have p. So we're not going to be using p hat in this case. So you're actually going to have to calculate n times p, okay? So how do we do this? You just take the n times the p and you're going to do 420 times 0.30. That's going to be 126. And then you're just going to do the complement, which is 420 times 0.70. That's 296, okay? So that's your, but you have to tell the reader why you did that. So let's read here. The stem of the problem states that the shoppers were chosen randomly. And since both NP and NQ are greater than 10, we can assume the distribution is approximately normal. Now you can say it's okay to proceed. So once again, this is the only case where you will actually use P, because you actually have it. So I always say, if you have your true proportion, you use it. Okay, moving along is the formula is step 3. So step 3 is our formula. It's always a z-score, never a t. Statistic minus parameter divided by the standard deviation of the statistic. Once again, in this case here, we have P and Q in the denominator. Remember, if you watch the confidence interval videos, we don't have P and Q, so we estimate it by using P hat and Q hat. So how do we do this? Z is equal to this. Now, we said it was 420. This is 420. I forgot what the numerator was, 135. Okay. So now we have to calculate this. We're going to take out our calculator. We're going to go here. I like the yellow highlighter. We're going to do one prop z test. Remind yourself that all hypothesis tests are number 1 through 6. After you do that, you're going to p equals 0.3, numerator, denominator. I said greater than. This is the calculate button. After you do that, you're going to get these numbers here. This is your z. This is your p-value. This here is the p hat. So if you basically took the 135 and divided it by 420, that's what you would get. This is your n. So we need 0.96 is basically your z. Okay, so 0.96, that's all in step 3. We need our p-value, and then we need our conclusion. I'm just going to do it on the next page here. So the probability that z is greater than, right, because this guy is positive and we have the more than, the probability that z is greater than 0.9583 is equal to 0.1690. So that's going to be bigger than 0.01 and 0.05, so it doesn't really matter what you choose. So step 5 is our conclusion. And what are we going to do in this case? Assuming that HO is really true, okay, we, since the p-value is greater, so let's put the p-value, even though it's right above, is greater than alpha equals 0.05, we fail to reject HO. We have, we do not have, because we fail to reject, we do not have sufficient evidence to say that the returning number is greater than 30%. The true proportion of shoppers is greater than, so we don't have evidence to say that. So basically your first statement will always be either we reject or fail to reject, and your HO, and your second statement must be about HA. We don't have evidence to say HA. That's pretty much how you do it. So take your time, make sure you know how to use the calculator, and that's pretty much it.